Good afternoon, ladies and gentlemen, and a very warm welcome to Reimagining Tech in 2022, presented by Google Cloud and ETCIO. To help IT decision makers in meeting digital transformation goals for their organizations, ET and Google Cloud have come up with an innovative series of 10 workshops around cutting-edge cloud technologies. The sessions have been conceptualized keeping in mind IT leaders who are looking to gain action-level insights to support their organization's digital growth strategies. Today's workshop is on the topic Achieving DevOps Transformation for Excellence in Technology Delivery. This workshop will help you and your organization build better teams and better software while also maintaining work-life balance. Ladies and gentlemen, we will also have a Q&A session at the end of the workshop, so you can keep posting your questions and our speakers will be happy to take them up. Let's kickstart today's event. I would like to invite Mr. Marut Singh, Chief Technology Officer, CAST24, for a keynote address. Welcome, Mr. Singh. Pleasure to have you here. Over to you.
My name is Marut. Currently, I am working in the capacity of CTO of CAST24. I joined the company around 4.5 years before. So today I am handling almost 200 member team at CAST24, and our primary tech stack remains backend remains in. We are like Java heavy shop. On front end, we are all JS. Mobile applications are React Native, though we are very interestingly looking into Flutter these days because gaining a lot of traction, and we are just evaluating which is a better future oriented technology, whether it's Flutter or this React Native, right? So once we develop the application, we'll get to know the results. And our approach in CAST24 has been to experiment through various frameworks, technologies, databases, caching frameworks, and we pick what we feel is the best fit for our use case. CAST24 is a tech-driven company, right? We utilize technology in all our business process automation, right? Objective is to give a standard experience to users, right? To give a consistent experience, not only in India, but wherever we are present. So if you are buying or selling a car, let's assume, in Delhi, and you have had certain type of experience in terms of, the pricing, the negotiation, the way, the document collection, right? How the payment is actually created is credited into your account. Then I want the same experience to be reflected in Kochi or in Bangalore, right? Or in Northeast. How do I create that consistent experience, right? Then we need to take out human biasness, right, from the entire process. So we try to automate things as much as possible. We build a lot of internal softwares, whose primary job is essentially to remove human biasness and create a consistent experience by standardizing the whole process. For example, we have an auction platform where we ask people to we list all the cars that are coming to us, and after a thorough inspection of the car, we invite all those bids from the interested parties. And how does that happen? That happens through an app called Dealer App, right? That is our auction platform. And this is on the seller side, and on the buyer side as well. We are trying to create experience which is more digital for the buyers, and they can actually go and look at all these cars, see as much detail as possible, right? Leave no room for ambiguity before they come to our yard and stores, right? Before doing the test drive. And if they have to book the car, they can actually make a payment online. And then, the whole process, we are trying to make it as seamless as possible. So all this requires, of course, excellency in software development. We experiment a lot. That means we have a 2-week release cycle. In that 2-week release cycle, that is pretty standard across many of the other startups as well, right? In the 2-week sprint cycle, we try to release useful features to the users at regular intervals, right? Now, how do we release those features? So one aspect is, of course, there is like requirement gathering and documentation, which is then created into a TRD format by the product managers, and then it is given to the development teams. They do the development, and then their whole system testing and everything needs to happen, and then all this final piece of software needs to be delivered, right, to our central cloud, right, where so we are hosted on GCP for the buyer side products, and during this process, right, speed becomes very important. That how fast you are able to deliver this feature, how fast you are able to innovate, how fast you can reach out to your customers, and if those customers face any problem in those features, they can report to you and you can immediately fix them and again deliver them. Right? Deployment, what we call deployment, or the final leg of the delivery of the software becomes very critical, because if you see the software development life cycle, right, and how the software was being developed, right, like 15 years, 10, 15 years before, there used to be long release cycle, right? So you will release a software today, you will give it to the customer, you will gather their feedback for next 3 to 6 months, and the release cycle happen either half yearly or yearly, which will actually give you a lot of time to do planning, testing, and then deploying in the production, right? But these days, for startup like us, speed of execution becomes very important. We want to be much faster compared to our competitors, and because of that, we build our software in a very distributed fashion, right? What we call microservices is a very popular term these days, right? But it's nothing but distributed software. So we create these small piece of softwares or called services, and then we push them into production, and these services they interact with other services to build whole user journey, right? And this creates a problem, right? What is the problem is that you have made certain changes in a service which is not really expected by the service, right? Because these two teams are not talking, or these two teams have no idea what other team is actually working upon. There is always a likelihood that you may end up breaking, right, these integrations, and if you come to know about them in production, right, it will be a total disaster, right? So in order to solve problems like these, it is important to have integration test cases, right? And if you have integration test cases, then you have a piece of code which is actually running, and that can call these APIs from other services, and give you the final test result, and that this test result has to be published to the teams, and if something is broken, they need to work upon it, fix it before it goes into production. And once all the test cases are actually passed, then you push for final delivery in production, right? And this process of continuously developing, right, and delivering requires what we call CI/CD tool, right? So this process is called continuous integration and continuous delivery, in which you are, before releasing the code into production, you have to make sure that nothing is actually broken, right? And so the first is that you need a piece of software that is helping you organize this whole multi-services distributed architecture, right, into production. So there are certain steps depending on your environment that you would try to automate. Maybe you want to run certain test cases using a test case framework, like we use Java, right? So JUnit is pretty popular, and you want to run all these unit test cases, integration test cases, you'll need a CI/CD tool. So we used to have Jenkins earlier, and then we migrated to an enterprise tool called TeamCity, right? So TeamCity is an enterprise tool. Why we moved away from Jenkins to TeamCity is primarily because we were facing issues related to permissioning, right? And we needed something that is more robust in that. So what we did is that we invested into TeamCity, and we were able to control, each job's permission as per the user's role, right, into the system. So essentially what we did is that we tried to control, we tried to control these permissions based on user's role, right, for particular jobs, because a team A should not be by mistake should be able to deploy jobs, right, and the new versions of the team, because if that happens, right, it's a disaster. So you need better control, right? So even though you can do it in Jenkins, we didn't find it very robust, so we ended up using TeamCity, and we keep taking decisions like this from time to time. We realize that a process which is not very robust, let's go and find out a better tool for that, right? Now comes the packaging part, right? That once we have written the code, how we are packaging all these applications, right? We package all these applications in the form of containers, right? So we use Docker, for a very long time. It's been almost 2.5 years that we started utilizing Docker, and which is our base of creating images. And then of course there is a Docker runtime, and what you need, if you have a lot of these services, then you need an orchestrator, right, to manage all these Docker images, right, in production. How to run them, when to stop them, when, if you want to upgrade them, if you want to roll back, right? How will you manage all these, let's say, hundreds of services that are running into production, right? So you need an orchestrator. So we use Kubernetes as our primary orchestrator, and we are using, there are various flavors of Kubernetes available in the market. Since we are on GCP, we use GKE, which is the managed Kubernetes environment provided by Google, right? And we have a set of nodes that are part of this Kubernetes cluster, and all these services run on that particular node, right? So the idea is that you should be able to not only write code fast, but you should also have the capability to release that code into production as fast as possible, right? And if you want to do that with confidence by making sure that something wrong might not happen when I release this piece of service, because this one service is part of a larger ecosystem, right? There are hundreds of services are running, and something might go wrong if you make even one line of change, right? So you need that confidence. Then you need a more robust process, and that robust process is CI/CD, and there are various ways of doing it. We have integrated various tools. We use, of course, EML files, GKE, Docker container, and then all this is managed using using TeamCity. But there are other tools that we have explored, right? So Cloud Build, Google Cloud Build is another such, which is completely stateless, right? So that is also a amazingly good tool, and a lot of friends in my circle, they use it effectively. But we have already invested in TeamCity, so we are going ahead with that. But Cloud Build is something that can be explored, right, because it is completely managed, so you don't have to install any software or anything. You can simply go and write these YAML files, and you should be able to get CI/CD processes in place, right, in a very less effort. Now coming to this, right, there are, after you deploy, right, then there are other things that come into picture. For example, monitoring. How do you do the monitoring, right? So monitoring, logging, right? And again, for monitoring and logging, there are various tools available. So we use, for example, something called Datadog, and Datadog containers have to run as a sidecar proxy to the main application, so that it can collect all those monitoring matrices as well as logs from the application and push it into a central repository from where you can go and search through these logs, relate these logs with, other services. If there are any issues, exception, etc., you can go and, filter out, right? You can look at the matrices like, CPU usage, memory usage of the application, find any bottlenecks in your application's performance. And, they have got very nice um, uh, AI inbuilt, which will actually find anomaly if your applications are breaching a certain threshold from SLA perspective. And then you can go and basically work upon it. There are tons of other features, right? They can also monitor, your host CPU and everything. And then you can see whether, because when you are delivering at a very fast pace, it's highly likely that you will end up breaking something, right? No matter how careful you are, right? So these sort of monitoring tools are available. Now the question is, if I am deploying my main application, how do I make sure that Datadog is also seamlessly integrated into that? Because some might forget that, right? So you need to automate that process. Again, CI/CD basically comes into the picture, right? So you can write your deployment pipeline easier using something called Cloud Build, or you can use, Jenkins or TeamCity or, other tools as per your area of expertise. So the whole point about moving fast is that every step in the software development process needs to participate in that, right? If you are able to develop software very fast, right, understand the business requirement and develop the software very fast, but if you are not able to deploy in production, and if you are not able to deploy with confidence, and just in case if you happen to deploy, right, with confidence also, but every now and then things break and you are not able to find out those issues and fix them very quickly, right, you will inherently keep getting into problems which is slow down your delivery, right? So you have to be very sure, you have to build a very robust CI/CD processes which will make sure, right, that there are no blame games in the team, and you can figure out issues quickly, work upon it, and then redeploy again, right? For example, can I identify an issue? Let's say even if I identify an issue within 5 minutes, my teams have reported it to me, the people are not able to make a payment, right? Let's assume, that is the case for whatever reason. Maybe, there is a problem with the payment gateway. Maybe there is a problem related to the way we are calculating all those amounts, right? Or maybe there's some other issue. So if the payments are not happening, there is a panicky situation. Do I have the confidence that my team can go look into these monitoring tools immediately and be able to fix the issue and deliver it? That will not happen unless I have built this very robust CI/CD pipelines, right? So essentially, a lot of problems are solved by, let's say, using Docker, right? So Docker came as a solution, right, to the problems which sort of tried to not completely, but to a large extent, try to remove the dependency on the underlying operating system and different versions of library, as in a few other things. But if and there's one problem Docker solved, then Kubernetes solved the problem of orchestrating, and Kubernetes also evolving on a regular basis, bringing new features, solving new type of problems, right? But like I said, right, it's just one part of the story. If you don't have a robust CI/CD process and build, right, you will still find it difficult to deliver software into production at speed. So it's absolutely critical. I mean, we do face a bunch of other problems. For example, one of the challenges that we faced is we are not able to move fast enough because of the Nginx based ingress that we were earlier using, which is very popular open source ingress, right? And many companies do use it very effectively in production, but we wanted something which is much simpler. So we used a tool called Ambassador, which is Envoy based API gateway / ingress controller, and they have created a very nice CRD, right, called mapping, which helps us to map all these services, right, to the right URL paths. So we look at what we have, if we can do better, if we can do it with more confidence using an enterprise technology, and if we can incorporate that into our budget, we go and certainly invest into it. That has been our approach. There are some other problems that we face, that we are not only an India-based company, but we have expanded into other countries, right? So we expanded into, we started with Australia, then we went to UAE, and now we are present in Thailand, right? Thailand and Indonesia has been launched as well, and Saudi Arabia probably will be next. So we had this global ambition that the problem that we are trying to solve is not just India focused. There are other markets that we can go and try out our business model, and so far we have been successful, and hopefully this success run will continue, right? But the thing is, how do you make sure that without investing too much, you are able to support all these countries, right? You are able to make sure that, the team that you have is able to deliver and support all these, products, for different countries, because a lot of these products needs to be customized, and depending on users' preferences in other countries, we go and deeply research users' behaviors, and then we try to customize our checkout flow, for example, and a lot of internal tools, they need to be customized, because the way we refurbish car in India is very different in UAE, for example, right, or in Australia. At some place, manpower costs are very different compared to India, right? And some place, the processes are different, the rules and regulations are different. So we need to change and adopt. But still, we don't want to sort of multiply our engineering team, right? Because as a business, we have to make sure that we are efficient enough. So how do we do that? We do that by leveraging all these automation and beautiful tools available, because we were on Docker, Kubernetes, and we had very robust CI/CD pipelines into place right from the beginning. Right? They actually help us make sure that we are able to deliver a new country in 22 man days, right, from the time that we get the requirement. Right. So once I get the designs for the new websites, we can actually launch a we can support a new country, right, by launching a new website, right, in 22 man days, which I think is pretty terrific, right? And we further will try to reduce, right? We know there are some bottlenecks that if we solve them, we should further be able to reduce it. So idea is to automate wherever possible, and deployment processes are actually no different. From time to time, you will find out issues that if you automate them, not only is, and CI/CD not just limited to running, test cases, for example, right? You want to notify, various teams that, something has been released into production. Maybe you need to send an email, or you want to integrate with Slack, and you can do that using the CI/CD tools. Even Jenkins have a lot of available plugins. It's a different thing that we don't believe that much into Jenkins security. We think that it's a major problem. We use TeamCity mostly, but there are companies which have been able to do it more successfully. So whichever tool you pick up, you make sure that you understand it well. And if you want to start your journey into this, if you haven't already started, make sure that you start with if you are on cloud, right? I mean, I'm a promoter of cloud, as you can see that I don't believe in managing all this infrastructure on our own unless the cost becomes a very big factor, right? If the company is in a very initial stage. But if you can afford it, you should be using cloud. And in cloud, you have a lot of managed services, and many of those managed services will be able to help you build and release software much faster, right? And CI/CD is something that is also available in cloud, fortunately, and you can probably start from there, and then slowly graduate towards solving more complex challenges, right? As you come across, and depending on how your services are designed, what sort of interdependency do they have, what is the nature of those services. For example, we face this difficulty that at what point in time we actually want to deploy these services, because we are serving different time zones. So depending on the least user activity, just in case, if a problem happens, I should be able to have enough time to roll it back and make sure that the least number of users are impacted, right? So how do we do that, right? So we do that by, of course, automating as much as possible. So these deployment pipeline, for example, if you want to launch in Australia, they cannot be run during the day until unless somebody comes along and overwrites that setting, right? And we control that. So depending on your scenario, you will be coming across different type of problems, and you will have to essentially solve for them. But ultimately, what I would propose is that write code for that, make sure that you have automated that wherever possible. So that's it from my side.
Thank you, Mr. Singh, for sharing your insights and learning with the audience. Excellence in software delivery and operational performance can drive organizational performance in the era of technology transformations. To meet the demands of an ever-changing industry, organizations must deliver and operate software quickly and reliably. The faster your teams can make changes to your software, the sooner you can deliver value to your customers, run experiments, and receive valuable feedback. Teams that embrace the principles and capabilities of DevOps can deliver software quickly and reliably, all while deriving value directly to the business. Let's hear more about this from Mr. Chaitanya Prakash and Principal Architect, Google Cloud. Before that, a quick reminder to drop your questions in the chat box. Our guest speakers will pick the questions at the end of the session. Over to you, Mr. Chaitanya.
Hi everyone, I'm Chaitanya. I'm a principal architect with Google Cloud, and today I would like to talk about how can we leverage DevOps transformation to build and scale highly performing organizations. That's a key topic for today. And if I were to leave you with key messages ahead of time, the key messages are as follows. It is possible to build high performance organizations by leveraging DevOps transformation, and the key metrics within this are software delivery and operational performance, which can be measured and can be improved over a period of time. This is done by a combination of technical, process management, and product development capabilities. And these impact both organizational performance, software delivery and operational performance, and also the culture. And there are interlinkages amongst all of them, and then they build a virtuous cycle of improvement overall. Third, and the culture can also be measured and changed. And there is a whole notion of building community structures like communities of practice or grassroots or POC environments and so on that can help bring about these organizational changes, activated and accelerated by the transformational leadership, which I'll cover towards the end. But these are the key takeaways if I were to leave you with the messages at the beginning. Now, let's look at what DevOps actually is. We did discuss DevOps, the key messages, without actually getting into definition of DevOps. But what DevOps is, there is no one canonical definition for what DevOps stands for. This is by design because it is still evolving as a community. We are learning to know how to get better at building these practices and also operate this for different kinds of software systems, and it is evolving as we are doing this, right? So this is the definition that we practice as we stand today. DevOps is an organizational and cultural movement. Yes, it is an organizational and cultural movement which aims to increase the delivery velocity, improve the service reliability, and most importantly, build the common ownership or shared ownership among all the stakeholders that are involved. These are three important things that DevOps constitutes of. Now we'll look into each of those, first starting with what software delivery performance is, which includes all the aspects around delivery velocity, service reliability. Then we go to the shared ownership, which is more the culture and the autonomous teams part towards the end. First, let's look at what software delivery performance entails and how do we measure that, and why is it important? This is because what is known, the most important result that we've observed by looking at various firms across different industries, different sizes, for over 8 years is that this result stands out. Software delivery performance gives the organization competitive edge towards their organizational performance goals as well. For example, what we noticed is elite performance on software delivery are twice as likely to meet or exceed their organization performance goals. This can be profitability, productivity, acquiring more customers, the operating efficiency, and so on. These have business implications and drives the business performance outcomes as well. So these are not just practices, but also have tangible outcomes at the end of the day. The software delivery performance has two key metrics under that. If we structure these metrics, one represents speed, which talks about the lead time of changes from the version control to the time the service is actually deployed and running in production. The second is deployment frequency. This talks about the number of times you are making changes deployed into the production environment. The second key metric talks about the stability. It once again has two submetrics inside it. One is the change fail rate, which means when you push a change out, how much percentage of time do you have to remediate or fix an error or a failure that happened because of the change. And the second is when you notice a failure, how much time does it take for you to restore the service back? These two represent the stability metrics. And together, these four metrics is what we call as software delivery performance constitute. And these are generic enough and applicable to any kind of software delivery, be it firmware, mobile, or even operating systems. It applies equally to all. The operations performance, however, is measured via a metric called reliability. This is a new metric that's been introduced in 2021 State of DevOps report. Erstwhile, till 2019, we used to collect this as an availability metric, but reliability is more encompassing, including the availability aspects as well, that also looks into the operational performance. So these five metrics together can talk is how you can measure and also improve upon both software delivery as well as operation performance. I talked about elite performance at the beginning, right? So, however, there is actually a definition against these four metrics, depending on the gradation where an organization falls, becomes which category the organization belongs to, right? If there is one takeaway that you can take from the slide that I'm showing is that high performers are not doing a trade-off between these four metrics, but trying to achieve them together. For example, elite performers do not trade speed for stability. Rather, they try different approaches to get more improvements on both speed and stability, and at the same time focusing on reliability and quality of the services. This is similar to what lean revolution happened in manufacturing, where Japanese giants like Honda and Toyota were not only building better and cheaper cars, but they were doing faster. So there is no trade-off or a zero-sum game here. All of them have to be achieved and can be achieved collectively. And done correctly, these capabilities drive higher speed and also enable higher levels of stability and reliability for your organization. As an example, when we cover or measure the elite performers against the metrics like deployment frequency, lead time to changes, time to restore or change failure rate, these are some startling or surprising results that we see. Number one, the elite performers have 973 times more frequent code deployments and 6,570 times faster lead time from commit to deploy when compared to a low performer on these metrics. Elite performers are also 3 times more likely to experience any change failure, which means their changes are less likely to fail 1/3 of the time. And also, they are 6,570 times faster to recover from incidents because their lead time to commit to deploy is 6,570 times faster, which also means their time to recover will also be much higher. So these are some astonishing results that you can achieve as an elite performer in comparison to where you operate today. And this result stands hold independently of size of company and industry. You can look at, we've looked at companies ranging less than 5 employees to 10,000 plus, and also industries ranging various from technology to financial services, healthcare, and so on. And those metrics and the observations stand across all of these sizes and all of these industries. In fact, we find high performing teams in large, highly regulated organizations like financial services or healthcare, but we also found some low performers even in technology startups. So it is how an organization implements these gives them the results. It's not necessarily dependent on a nature of the industry itself. And especially because large organizations are also heterogeneous, you will find both kinds of low performing and high performing teams inside of them, which is also another interesting observation we have. With this, what I've established is how software delivery performance and operation performance can be measured. We talked about speed and stability metrics and how those help you measure your organization performance and move towards high performance teams within your organization. Now let's take a look at the high performance teams in a bit more detail. So this is what we call as big friendly diagram. While you not be able to see the whole thing, the key message here is there are 4 features that drive the organizational performance, and there are interlinkages between them. Technical practices, lean management practice, and product development practices drive both software delivery performance and also the culture. So, which necessarily means to improve culture also, you need to implement these capabilities. And together, the organizational culture drives both software delivery performance and organization performance. So there is sort of a virtuous loop of all of these coming together to improve the culture, and that helping the organization improve on the software delivery performance, and that helping further improve the culture, and then also delivering on the organizational performance goals. So that the virtual cycle builds across these 4. While there are a lot of these areas, I will drill down on the 4 aspects that are related to this, starting with 1, continuous delivery, 2nd, lean management and product practices, 3rd, mission-oriented culture, psychological safety, and lastly, autonomous teams in a bit more detail. What is continuous delivery? The core of the meaning of continuous delivery means to make releases boring. All of you might have been in situations where you've deployed an urgent fix to production or released a new feature on a tight timeline where you had to do it over a weekend or in the evening. That's an experience that most of us have had. But the whole idea and notion of continuous delivery is to avoid that and make releases boring, so that deploying software to production should be a continuously low risk activity that can be performed during normal business hours at the click of a button. And this does not mean only the production deployments, but it also talks about all kinds of changes, including database schema changes, network changes, infrastructure changes, and all of it done in safe, quick, and repeatable and sustainable manner. That's what continuous delivery focuses on. And to implement continuous delivery, there are various technical practices that needs to be put in place. I'll comment on some of them. For example, doing trunk-based development instead of feature branch based development practice, bringing in continuous integration into the whole process, trying to shift left security, reliability, and practices so that you build as much of these practices ahead into your processes like development itself, rather than doing it once you have deployed it into a particular environment. Focus on loosely coupled architecture. So various components of the system can be deployed independently from each other, and bring testing as early as possible into the whole ecosystem. And when we do all these changes, this continuous delivery through these technical practices help the teams also have a lower burnout, and also have reduced deployment pain, and also avoid a lot of rework. And all of these again have cultural implications, which we'll discuss in a bit, and then also improve the software delivery performance, which affects the organization performance. And all of this is hard to implement, but there are these practices which can be iteratively brought in one by one, so that at a point the organization is able to confidently deploy changes to production without any manual change approval board or a process, and then release these via a CI/CD pipeline, as we typically call it, to the production environment. I touched upon how should we bring a lot of reliability, security aspects early into the cycle, right? And this is one of Deming's 14 rules. Cease dependence on mass inspection to achieve quality, improve the process and build quality into the product in the first place. And what it does that mean is, instead of doing the inspection of the quality of the product after it is built, can you bring these practices as early as possible and bring it into the product itself? For example, in software context, can we look at processes such as pair programming, or having a code review practice, a pull request based model that ensures that the code is reviewed by at least 2 or 3 approvers before that gets deployed as early into cycle, rather than once the product is built, then it is handed off to a testing team, then it is handed off to a user acceptance test team, and then getting into a production, which would be more of a reactive approach. So how can we bring many of the quality assurance practices as early into the processes, right from the development, which is ideal, is the key message here. And this also is the pattern for this continuous delivery is this deployment pipeline. Right? The goal is to find all these problems as early as possible, so that we can act upon them. What you notice here is feedback cycle that is built into every single stage of this pipeline. For example, once a change is committed from the version control, before it is approved, there is the code review process that gets triggered, and based on the approval, there is the feedback that is going right there. Once that is done, the code will have automated tests that are run, and again, if some of the tests don't pass, the build is rejected there itself. Again, you have the feedback process going back for you to fix this build for the next run. And then once that is done, then again the change is then propagated into lower environments to higher environments using some sort of an approval process, which, as your confidence improves, as you move things related to security, quality, reliability in an automated fashion, validation ahead of time, the confidence will build in terms of releasing changes to production in an automated fashion. Or till that time, we see organizations do a lightweight change approval process, rather than building the whole, a CAB or a change advisory board who sits and validates and takes weeks to approve the changes to get into production. The key message here is build feedback into every stage of the deployment pipeline, and that can help accelerate this whole deployment process and reduce the lead time. Lead time is how much time that the organization takes to deploy a change for a one-line code in a repeatable fashion. And this is in conjunction with the time to respond. When you find a vulnerability in your stack, how long would it take for you to find, patch, and redeploy the impacted applications or services? These two together actually calls into the view on the stability metrics as well. So using which you can also assess how quickly or how slowly you're propagating the changes into environment, which again has business implications. Imagine there is a failure that you need to fix faster because your feedback process is not there. The lead time is higher. Your ability to respond or release the bug fix is also going to take equally long time. We talked about shifting left a lot of quality assurance practices. One is definitely security. What we find is elite performers build security in the sense of conducting security reviews and completing all the security related changes in matter of days instead of making it a long drawn process. They try to shift security as much left as possible, including bringing it at the design stage itself, and then also making security tests part of the deployment pipeline. The teams also are helped by the InfoSec teams by providing pre-approved libraries, packages and tool chains and processes so that you have pre-approved templates to start your development on, which makes the propagation or the deployment process quite faster. Uh, and also the entire architecture itself be loosely coupled. I'm going to talk a bit on autonomous teams towards the end, but the architectural outcomes here talks about how can you implement changes faster, and by that we no means saying that only you should do the work on, let's say, a Kubernetes cluster in a containerized fashion, only you can roll out faster. These are practices that are applicable even if you plan to deploy on mainframes. For example, how can my team make large scale changes of the design of the system without taking permissions from somebody outside the team? Second, can complete the work within the team without having a very fine-grained communication that requires coordination with every single stakeholder outside the team. Deploy and release its product on demand, but more importantly, independently of other services or products that the service depends on, which is the loosely coupled deployment as I was referring to. How the teams can do testing on demand and also often can generate environments on their own rather than depending on one single integrated test environment where all tests need to run and then pass. Lastly, how the team can perform deployments in normal business hours without any downtime, without any significant downtime. So this is what architectural outcomes talk about. And what we see is most people who leverage cloud are more likely to have many of these capabilities available for them, and elite performance are 3 times more likely to meet these 5 characteristics such as on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service to bring that software delivery performance into their organization. While teams have been adopting cloud over a period of time, what is important is not cloud alone, but the practices that are stitched in also makes the difference. For example, the on-demand self-service is one of those attributes, right? Even if I have to raise a ticket for a particular environment to be spun up or a VM to be spun up, and I wait for it for multiple days, then you're not deriving any benefit that a cloud platform would provide you, which is having the infrastructure provision to you in seconds, right? So hence, it's not just adopting cloud, but adopting these 5 practices as much as possible, like on-demand self-service, broad network access, resource pooling, rapid elasticity, and continuously measuring the service outcomes to improve your software delivery and operational performance are important. So cloud is a differentiator, but how you implement is also equally important. We talked about continuous delivery so far. Now let's look at lean management and product development. Our research shows that even lean management and product development practices also impact culture, burnout, delivery performance, and in a sense, the product development drives the organization performance outcomes. The software delivery performance also impacts the lean product development as well. Let's look at lean management practices first, right? So it has 4 things or 4 practices that constitute under lean management. 1, limit work in process, visual management, feedback from production, and lightweight change approvals. What is interesting when we did the research through DORA and then realized is that limiting the work in progress process to small chunks alone is not a guarantor of improved software delivery performance. But when we look at all three of them together, lean work in process, visual management, which is showing what is the current status of, let's say, the work that is at different stages. Maybe it is at build stage, maybe it is at a deploy stage, or maybe there are the number of bugs that the team is working on, the backlog that the team is carrying, visually representing that along with the work that is being done. And as they deploy, the feedback in terms of the various metrics that are observed, how the performance has changed, the user feedback, etc., that together actually drives the software delivery performance. So not just implementing let's say, an agile practice of monitoring how a story is implemented, but also how it is actually reflecting in terms of the team's development cycle, the practice is visually represented, and the feedback that you are getting from your end users also roped in will help you drive a better software delivery performance. The last one, lightweight change approvals, is what we've discussed a few minutes back in terms of ensuring the change approvals to be done using lightweight process and as much early as possible. For example, can I look at pair programming as a way of change approval, or code review across, let's say, two developers to ensure that the code that is checked in can be pulled into the changes that are going to be released next, right? Into the next release. So that is what lightweight change approval talks about. It's not about creating a change advisory board and then use that to then review every single change that goes as a group, and then which actually takes more time, which affects the speed part of this software delivery performance, and will again negate the impact of the automation and the rest of the work that the team has put in. So lean management practices hence constitute these four. The first three of them go hand in hand to drive software delivery performance, but the later one has implications on speed and also needs to be brought in as much early into the development cycle as possible. Now, looking at the lean product development, right? You would see it has implications or learnings from lean management too. Here it is about working in small batches, making the flow of work visible, gathering and implementing customer feedback, and then team experimentation. These four again are similar. They have both implications on organizational performance directly, but they also have impact on software delivery performance, which in turns also impacts organizational performance. Let's take one example, which is a team experimentation. Many agile implementations talk about implementing a particular framework, no deviations. This is my story card. These are the actions that my developer has to do, and this is the success criteria, and the team just has to do this. What shifts there is, let's say, instead of team sitting and then having the sprint planning in a meeting, maybe you're doing it standing up. That's the difference. But the essence of agile and lean is to try things out, let the developers experiment different approaches, and through that generate ideas that can help further drive the organizational outcomes. So the spirit of experimentation need to be brought into product, not a fixed way of doing things across the cycle. So while process is important, again, these aspects around experimentation and freedom to try out things and ideas also directly impacts the organizational outcomes. The last one, autonomous teams. Before I'll cover autonomous teams in later slides as well, but this is one of the definitions of autonomous teams in practice at Netflix, right? You can relate this to the architectural practice of having loosely coupled services, right? Here, the autonomous teams, firstly, you want to ensure loose coupling, which neatly ties into the architectural outcomes we described earlier, right? Each of those cross-functional teams be able to deploy their own services, artifacts, independent of others. So in that way, they are loosely coupled, but then they are still cross-functional. The second, however, there has to be an overall alignment, because the teams have to be pushed in the same direction, right? So should be pushing in the same direction. And that's the reason the high alignment, while the teams itself being loosely coupled. Now let's look at the third part, which is about mission-oriented culture and psychological safety. The model from Ron Westrom, a sociologist who studied safety outcomes in healthcare, aviation, nuclear power, etc., has created this typology of culture and safety outcomes. He categorized organizations into three broad classes. One is pathological, which means more power oriented. The second is bureaucratic, which are more rule oriented. And third is generative, which are more performance oriented. Against these three classes of organizations, there are 6 dimensions across which they are measured, right? The first one is cooperation. Whether the cooperation between teams and within teams, how is it? Is it low, modest, or whether there is high cooperation? Second, how is failure treated? For example, when a failure happens, what happens to messengers who bring bad news, right? Will they be shot? Will the messages be completely ignored? Or you ensure that the failure messages are also communicated in a manner that the team takes feedback from it and improve the processes. The third one is responsibility. How is responsibility and risks looked at? Whether responsibility is avoided, or there are very narrow set of responsibilities that each team constitutes and they only operate for that and the rest of it they do not worry about, or are there a shared risk model that the teams look at where people are willing and able to discuss about various design decisions, the performance feedback, the failures that the system has had, and then collectively come together to create and plan to address that and improve the systems going forward. The fourth one, bridging here refers to how teams collaborate among themselves, right? How is many times when I work with different organizations, I get asked this question, right? So has this been, discussed with, let's say, a security team, or has it not been discussed with the product team? And they asked explicitly not to discuss this with the product team because they feel that the product team would not want to support the initiative that this team is doing. And this actually creates silos of information and the information asymmetry between different groups that are involved. And if there is no transparency and the teams cannot come together and then collaborate together, then again the has cultural impacts, right? For example, in a pathological organization where each entity or a business unit or departments operate as a silo, to more performance oriented where teams come together, have shared objectives, and then work collectively towards the goal that is addressed, and there is no information asymmetry across these divisions. The last two are like sides of the same coin. One is failure, the second is novelty. How is failure treated? For example, is there a blame that is assigned? Let's say Chaitanya has created this failure, so Chaitanya needs to be fired, to the effect of, okay, or on the contrast, do you look at, okay, there is a failure that has happened. What were the situation that led to the failure? What were the conditions that triggered it? And how can we look at tools or processes or remediation steps that will help us avoid such failures in the future? Which mindset are we coming at? And that is the second side of the coin, which is novelty, because novelty means experimentation, and people innovate and experiment, then failures do happen. And if there is no tolerance for failure within an organization, which means novelty continuously gets crushed as well. So to really have innovation as part of the culture, the acceptance of having failure and looking at the processes, practices that led to a failure and then continuously improving it in a blameless fashion is what is needed. And that's what a performance-oriented culture looks at. High cooperation, risks are shared, cooperation more broadly welcome. There is less information asymmetry. Failure is actually in a way celebrated because that gave a lot of learnings to the team and also continuously innovates. And this is not vastly different from what Google also found in the research that they've done on various high performance teams within Google. There is this project called Project Aristotle, which you folks might have heard, that looks at various aspects. And what was interesting was teams that are highly performing really did not have like a Stanford graduate or a Harvard graduate to lead those teams, but rather teams that were highly performing had these 5 attributes that are listed there. And the first and foremost thing, in fact, even the second one is the same finding as what Westrum's research also talked about. One is psychological safety. It is a way in which we can share the risks that are there within the organization or failures openly, transparently within the team, so that we collectively improve the product, service, practice together. And then also the team members can get things done by relying on each other, and that drives for a higher bar for and that approach also strives to drive towards the higher bar for excellence. These two are very common with Western, but the first one, psychological safety, is also determines how well your path to better software delivery performance and operational performance is also improved upon. And as we said, why is this important? Because we get a lot of learnings from failures, right? Which means to learn more, if you can simulate more of those failures or accidents more intentionally and purposefully, you will be able to get those learnings more faster and then improve your systems and the reliability. We talked about the operational performance too, right? In continuous fashion. This is what Google does. Google does something called as disaster recovery testing, which is ensuring that some of the components and services that are dependent are made to be purposefully failed, and using that we understand how the rest of the systems are performing, and that learnings are then continuously fixed so that in the next cycle of dirt testing the systems are able to improve which improves both the stability as well as the operational performance or reliability of the system. So this is one way in which you can induce into the culture the ability to introduce failures and also learn, adapt within the system, the processes, to ensure that you're able to recover from that faster. The last one is the autonomous teams, right? On the autonomous teams, we discussed earlier on that architecture outcomes on how independently a team is able to deploy their services while collaborating with cross functions is one dimension of the autonomous teams. But if you look at autonomous teams overall, again, it impacts software delivery performance and reliability, but the trust and voice, which happens when people within a team can trust and then speak up about the issues that they're facing within the organization culture, while directly improves organization performance, they also improve software delivery performance. Some of the learnings that we have when we looked at this process is the autonomous teams tend to be cross-functional, and if you outsource some of the functional components to different teams, that again negatively affects the software delivery performance. For example, let's say there is an organization which has outsourced, let's say, a development and the operations to two different teams, right? They are more twice as likely to be operating as separate and siloed, especially the low performers, in comparison to the allied performers, and then which also brings the challenges in terms of information sharing, collaborating effectively together, and then also bringing that knowledge in-house to continuously build upon the practices and build upon the culture, which would be missing the more and more you silo these functional components. So one of those asks, if you're planning to build a software delivery performance from dev and ops perspectives, is to bring the teams together, have them in-house, and then make them work together as the teams, right? And all of this to do, there are a lot of things that we talked about, right? The 4 aspects we talked about, right? From continuous delivery, we talked about technical practices related to it. We talked about lean product and management practices. Then we talked about autonomous teams and also overall mission-oriented and psychologically safe cultures to drive outcomes, right? Building all of it, delivering all of it takes time. It takes a lot of work. And the good news is we don't have to do it all at once. In fact, The DORA research that's been done, and it is published as a State of DevOps report every year. You can look up the 2021 report on cloud.google.com/DevOps. Talks about this, how organization teams, adapt to change and what helped them succeed and what did not. And if you look at various transformations, one thing what elite strategies seem to have created for a successful implementation of DevOps practices overall is by way of these four things. One, creating communities of practice, have grassroots involvement in many of these processes, not top down, bottom up. Third, leveraging proof of concept as both a seed and a template for driving experimentation and changes and innovation within the organization. And people ask about what is communities of practice and is there an example of it, right? Here's one. At Google, a community of practice called a testing grouplet was formed, which focused 20% of their time to promote unit testing across all of the Google projects that are available. And this is a completely all volunteer group with no funding, no direct authority, but they relied on persuasion and innovation to convince different project areas and Google developers on the value of unit testing, and provided them with knowledge and tools that they can use it to develop well. And that's how unit testing has been scaled throughout via this COP at Google. And there are so many examples like that. Last question that gets asked is, what is the role of leadership in this whole change, right? By leadership, we don't mean that it's only executives who we are referring to leadership, but every individual person is a leader who owns a change and has the courage to take a decision and then act accordingly. As per the big Venn diagram that we talked about, right? Transformational leadership also gives a lot of impetus and to this whole process of technical and lean management capabilities. It can be via intellectual stimulation by giving enough problems, by challenging the status quo. The team can learn about various things where there are bottlenecks and failures can improve upon. By inspiring others, we just talked about COP at Google to drive the unit testing adoption, how they were able to communicate and then provide supportive leadership through various tools using which they could advocate for unit testing implementation at widely across Google. And then also having the vision to change for a certain outcome is also helpful. And here's one example of a phenomenal technology goal that was set by the leadership, right? So double, half, and quarter every year, double the frequency of releases, half the number of low impact incidents, and quarter the number of high impact incidents. And this is directly talking to the speed and stability metrics that we discussed at the beginning. And then how all of that is measured and then now leveraged as a mission for the organization. Here in this case, it is HSBC's technology goals that I just talked about, how beautifully articulated on them to continuously measure and then be on the path of improvement for the software delivery performance, improve the organization culture, and thereby driving the organization performance goals. Thank you so much for your time. All of that I've talked so far is available at cloud.google.com/DevOps, which gives you more insights into the tooling, practices, frameworks that you can adopt to kickstart or move along in the maturity journey of your DevOps implementation within your organization. Thank you so much.
Thank you, Mr. Prakash. Now, ladies and gentlemen, it's time to answer all your questions. We'll pick the most pertinent questions as the time allows. Thank you, Mr. Prakash. Now, ladies and gentlemen, it's time to answer all your questions. We'll pick the most pertinent questions as the time allows. And I'm sure you all have liked this content very much because the number of questions that I'm seeing on my screen and the engagement you have shown. So now let's pick questions one by one, and let's.
Thank you, Mr. Prakash. Ladies and gentlemen, it's time to answer all your questions.
To our speakers here. So our first question is for Mr. Chaitanya. Our audience would love to hear more on security by design in CI/CD.
Sure, Annie. So during the presentation, we talked about how shifting security left and then bringing that as part of the continuous delivery process is important. We need to look at this more holistically, starting from your code writing phase itself. How can we have static code analysis as part of the initial the code development process itself? And once the code is committed, static code analysis is run, any vulnerabilities are identified, and then they're fixed. And then to the extent of then moving and building the artifacts, and once the artifacts are built, having the testing done against them, for example, finding known vulnerabilities in the application that is written, and then also looking at the final packaged binary, be it a container image or so on, to look at what are the various other dependencies and libraries that you're using and what sort of vulnerabilities also get injected into that. Once you do that, that is when you would sign the binary with more vulnerabilities or the signed off risks that you are aware of the libraries that are there, and using those signed binaries is what you would like to promote into your production environment. And that's how security can be built through every stage of the CI/CD pipeline, and it starts with the code writing process itself.
Okay. We have got one more question on CI/CD. This one we'll toss to Mr. Marut. How did you ensure adoption or culture change while implementing CI/CD? Marut, you are on mute. Kindly unmute yourself.
Yeah. So when you introduce any new process into your development environment, you need a buy-in from the entire team, right? You need to explain them various usages, various benefits that come out of, by following this particular process. And CI/CD is no different. So in a microservices architecture, right, when you build a monolith, it's a different thing, because there is only one set of application that you are developing. Everybody is checking in code, and there is only single delivery happening. But when you work with microservices, where you have hundreds of services running into production, it's very challenging to keep a tab on who is developing what, right? So integration becomes a challenge, right? Version management becomes a challenge. Somebody has changed an API somewhere, right? Somebody else's code actually breaks, right? And these are like very common high-level problems. There can be more complex problems in a microservices architecture because it's completely distributed. So you want to automate as much as possible, right? Including, security is something that Chaitanya touched base upon, which is also part of the entire CI/CD lifecycle. But one needs to be able to explain to the team that what are the various benefits that you will get, right, if you follow this. Initially, you may feel that you just checked in a code and there was nothing wrong with that code. It was working, just fine. You ran all the test kits and everything. But, something else broke. Maybe an integration test actually broke. And then you realize that, for no fault of mine, why did this happen, right? I need to, recheck and reload and, figure it out, whether the problem is because of my code or problem is because of, someone else's code. And it eats up into your development time. But what you realize that the more time you spend in building a robust CI/CD process and following it up religiously will save you tons of time in production environment. You will not have to, you can take a good night's sleep. You will not have, because, whether you are sleeping or you are, working full time, systems are always up, right? You are trying to chase 3.9, 5.9, 7.9, right? And depending on, your particular domain. And you want to make sure that no matter what happens, I should not be getting a call from either business or from an automated tool, and fixing those issues and figuring it out at runtime, right? So people who are more experienced, they know that development is easy, running code in production is hard, right? And they have to share their own experience. We have to share our own experience with the developers. walk them through, various scenarios. Sometimes, we have to go and actually simulate the production failures into the test environments and, ask people how much time it will take you to figure it out, right? And once they are able to see the clear benefit, then they are able to, and there, it is similar to, either code review or running security test cases in the dev environment, or maybe, writing unit test cases also, right? I mean, sometimes you tend to miss them. There is a temptation that you have to deliver fast, because in a high growth company like us, speed of execution matters, right? It is your primary mode. And in that case, you tend to, miss things. And if you miss things, you have to pay a heavy price at some time, in production. So people who have seen that, they can actually go and, start explaining things in detail. And that's how, you have to get people on board.
So I'm sure our audience don't want to pay heavy prices for that, and they'll keep your points in mind. And now, Marut, we have one more question for you, and that is, was Enthos part of your implementation?
Enthos is something that we have explored. Enthos has got many parts, and now what we are doing is basically we keep evolving our tech stack from time to time, depending on our knowledge of that particular system. Right? Since we migrated from AWS to GCP, so there are a few things that are very familiar to us, right? Which are like like to like mapping, right? But in certain cases there are things which are completely new, and Enthos is one such service, right? So we take our time in order to learn, to build that confidence, right? To understand its nuances. And I think Enthos is relatively new service, right? In GCP ecosystem compared to, let's say, cloud-based database management service or things like that. So it is something that we are exploring very seriously as of today, because we are using service mesh. We are using an ingress controllers. We use Ambassador and we use Linkerd for our service mesh. Ambassador as an ingress. But since we have expanded into different geographies, so now we want to use some of the existing services that are available in other ecosystem, right? And probably don't go through this deployment cycle, right? Again and again. In that case, we are looking for a multi-cluster environment where one cluster can seamlessly find out services running in another environment and interact with them, right? And at the same time, we are still able to take control of the security and other aspects. We are looking at Enthos very seriously because it's a great offering, but it's not in production yet.
Okay. So definitely our audience will look for in the future what you come up with. Next question is, how many environments you have?
Yeah, so it's a very good question, and very tough question to answer, to be very honest, because in a microservices architecture, right? And I know companies which have hundreds of environment, right? And there are some companies which prefer to have one environment for one developer even, right? What we do is that there are three core environments that we have. One is QA, staging, and production. And we try to make sure that sanctity of those environments is managed, right? Is maintained all the time, because there is a limit to which I can control what data is going on inside these environments, right? And if rollbacks happen, then database also needs to be rolled back and everything, and it has a huge cost. What we do is essentially to overcome this problem, right? That I am doing the development on my local machine, whether it is something that will work in QA or not. We use something called telepresence, right? Which is part of Ambassador abstract, which let us intercept the request coming to, let's say, QA service from QA to local, right? So any request that is coming to, let's say, QA environment, it doesn't go there, right? It will come to my local machine, right? And I can experiment with my code, right? And all the requests are coming, and debug it, right? And modify my code this again, and once I'm confident, only then push it to QA, right? Because I don't find that, there are different school of thoughts, right? There are companies which are ready to spend huge amount of money just on the infrastructure management, and got, let's say, 50-member DevOps team who can probably manage hundreds of environments. I don't think that's a right strategy. So we go with QA, dev, and staging. And what we believe is that if the code works on your machine, you should be able to push it to QA with confidence. and it has to work. And if it's everything, all the integration tests you can run inside QA itself, then go to staging and UAT happens. The real scenarios will be run by the business teams, and if that works, then we have got the confidence we push it to production.
Do you have any workloads on traditional on-prem data centers?
No, we are a cloud native company from day zero, and it is because of our experience that at some point in time we will have to move to cloud. So there is no point in I mean, at some point in time we had this big MySQL cluster, right, that we used to use, right, for analytics purpose. But then we moved our workloads to cloud, right, for the analytics also. Right now we run either queries on BigQuery or on Snowflake. But no, we don't have anything that is on-prem. And probably that is one decision that actually helped us, right, to move fast with a much smaller team.
I'm sure our audience are getting answers to what they are looking from our speakers. Now let's move to another question. This one is for Chaitanya. Is there any industry or sector-specific flavor associated with the DevOps transformation journey? If yes, are there known patterns available? Over to you, Chaitanya.
Sure, Anu. We did discuss in the presentation, right? So the findings of the report, which applied to organizations which have less than 10 employees, to organizations that even have 10,000 plus employees. And these organizations spanned across technology domain to traditional organizations like healthcare or regulatory based domains, for example, BFSI and so on. The findings of the DevOps practices and the improvements that you would get when you implement that in software delivery and operational performance is proven across all of these industries of all sizes as well. In fact, there is one of very interesting finding where large conglomerates also had pockets of teams which are much faster and innovative in development versus many technology organizations who did not implement these practices did not have the results that an elite high performer is. So it's really depending on the implementation of the practices, really, not necessarily the domain or industry specific focus that is. However, there is one part that you also asked about, right? The transformation journey part of it and what patterns are available, right? From that perspective, one of the insights to be looked at is whenever a transformation journey is taken care or initiated, it is better to look at where is the most value in terms of adoption of these and what are the low-hanging fruits. And if you take a look at both of these and then make a decision, it becomes helpful. For example, if you have an end user facing product, implementing these speed and stability practices will improve your product performance and in extension, even the organizational performance goals, right? So revenue or user experience and so on. Versus maybe an internal only facing workload, let's say only a batch processing that happens once in a fortnight, probably is not the first place to start with. So looking at what is the importance of the workload to start the journey with, and then how critical it is from the business perspective and how much complex it is from the implementation perspective, because there are various things that we discussed during the presentation. To apply them in an iterative fashion, how do we pick that should be the decision-making criteria on how do you start the journey.
I'm sure at this time of digital transformation and transition, these learnings will definitely help our audience in their day-to-day business. Now, let's move to next question. It's to Chaitanya. It's again for you. Best use of DevOps team or tool in IT team of any non-IT firm where IT partner delivering all the application.
Got it. This is a very interesting question because this talks about not the implementation within the IT organization, but talks about when a partner is engaged. Again, even when a partner is engaged, the exact findings hold good. However, if we look at, we did discuss as part of the culture as part of the presentation, right? So how do we look at this? It should not be a throwaway process just because there is a partner is there. So it's just throw over the wall and let the partner manage it. Enough care has to be taken so that these practices are implemented even if a partner is delivering that, and ensuring at the point of giving the contract to a partner that so and so processes need to be followed or practices need to be enabled even as they're developing, deploying and delivering the applications. should be a conscious effort, because that ultimately, whether built in-house or by a partner, affects the organization performance and what the customers of that product has in the market for that organization. So that needs to be kept in mind.
Sure. Moving to next question. How do you segregate apps or database for different geographic locations or for different countries? I'll put this question to Marut. Over to you.
Right. So there can be different strategies, right, for achieving this. What we adopted is that when we hit new markets like Australia, UAE, at that time we did not know what is it that we are dealing with, right? How these markets will behave, what are the type of challenges, right? These markets will have. What is the behavior of the customers, right? What sort of ecosystem is available there, right? For example, payments are very different in UAE compared to India, right? In some cases, India is like, way ahead in terms of, the IT infrastructure and digital infrastructure. Australia, it is very different, right? How we are sourcing cars, somewhere we have to get it, from the partners. Somewhere we have to get it from online platforms already available, right? So when you have to, quickly get up and running, you have to find those hacks. So because of these uncertainties, right, the approach that we took is that most of our common services, right, or what we call common platform, we simply replicated them across different geographies. So we have services which are running in Australia region, right, with a different cluster. Again, everything is on top of Kubernetes, Dockerized. So it's much easier for us to roll out those services, right? Just by changing few things in our pipeline here and there. But they are like one-to-one mapping, right? They are like exactly same copy, same replica, right, of the existing service that exists in India. And at that time, we did not have enough confidence, right, in multi-cluster communication, right? There was no service available, which is you just click here and there, right, a few buttons, and it gets you up and running. So we replicated everything, and then same is case with the database as well. For the users, what we do is basically we use Okta, right? Because security came into the picture. So it is something that we invested early on when we started scaling our B2C operations. So all our RBAC, right, are actually configured inside Okta, and we use Okta heavily, right, to give access to all our internal applications, because there are hundreds of types of roles, right, depending on where you are in the organization. So our approach is right now we are using a NoSQL. We are a very experimental company, right? So we experiment at all levels, including technology. So we are using a NoSQL called ArangoDB right now, and we run on-prem clusters of ArangoDB, and those clusters are replicated across different geographies. That is how we are handling it. But now we are, of course, right now this is basically the first level, right? Now the evolution starts. So now we come to know that Spanner is something that can solve lot of your problems, right? Like this. So we will migrate some of our workload from ArangoDB back to Spanner, and that will seamlessly solve our geographical problems, because GDPR compliance, right? When you are starting the business, probably not that important, but later on they become very important. For the consolidated view of the organization, right? For example, P&L, or let's say how many orders I'm doing, right? We create consolidated dashboards, and all those dashboards basically are powered through our data warehouses inside Tableau, right? So all the data from these different clusters, right, that gets synced to our centralized data warehouse, and that's where we power our dashboards from. So despite having different clusters, for the business user, it looks like one single unified view. That is a strategy that we have adopted. It is working fine for now. But like I said, we are already on to our next step, exploring Spanner, which is like a geographically distributed database, and already solved some of these problems. I met Google's VP engineering for databases yesterday, right? And we are looking into that. So yes, we'll keep evolving and keep reevaluating our strategy as we move forward.
Sure. Coming to Chaitanya, is it a culture element and essential prerequisite for a DevOps transformed organization as opposed to being a byproduct of things?
Sure, Annie. So Culture is both a prerequisite but also a byproduct of how you've implemented the organization, right? So throughout the presentation, we talked about how you can move from the low performer or DevOps practice maturity to an elite performer DevOps practice maturity by continuously and consciously measuring the four key performance metrics that we talked about related to speed and stability and so on. All of that have an implication on the culture as well. Uh, as you implement more of those practices and then improve your systems and the processes accordingly, that has a virtuous cycle of or a loop of creating the better culture within the organization. During the presentation, we also discussed about Ron Westrum's organization culture model and discussed about the typologies right from pathological, which is more where failure is punished, to more rule-oriented or bureaucratic cultures to generative cultures, which are more high-performance organization or performance-oriented cultures where innovation is encouraged and failure is celebrated because it gave you learnings to understand and innovate further. Now, how is this also a byproduct? As a team experiments and then implements, let's say, more of these innovations or novelty ideas within the team, uh, first, as the team starts focusing on the speed part of it, if they're able to deliver the code and deploy it to the production successfully by automating the processes, bringing a lot of checks and balances ahead of time, right from the code pair programming and code reviews early on to the time that you're running in production, and then also monitoring how they are performing, that also allows you to create bandwidth for your developers to innovate and identify or work on newer ideas that can further bring in innovation into the organization. So it's not necessarily a prerequisite. By also bringing a speed and stability and focusing on that through DevOps practice implementation would help you work on bringing more of these cultural aspects that are left out and then move closer towards the high performance or performance oriented cultures that we discussed within the during the presentation. So hence it's, while having a performance oriented culture is the can be a prerequisite for a successful DevOps implementation. However, that also requires to be matured over a period of time as you bring in more and more practices that you implement incrementally over time.
Sure. As we are running out of time, let's quickly take one or two more questions. So next question is how to do continuous deployment for database objects? I'll toss this question to Marut. Over to you.
Marut, you're on mute.
So depending on what type of database you are dealing with, right, you will have to, have different type of strategy. Now there are databases which are which enforce schema like typical RDBMS, and in the old days when there were not many tools available, you would usually write custom SQL scripts, right, to migrate the schema, to migrate the database itself, right. And now you have tools like Liquid-based, for example, which you can integrate with your Spring Boot applications, right, and they take care of most of the manual stuff, right, and you can rerun those scripts, right, to create the exact state of the database that you intended to. But like I said, not every database type, right, will be able to enforce this, because now there are NoSQL and there are NeSQL and there are graph databases, right? So whether you like it or not, you'll have to write code for managing those schemas on your own, right? Essentially what you do is, in a NoSQL, you manage schema inside the code rather than the database. So you write all those enforcement at the schema level itself, and you need to follow certain guidelines before modifying an object schema, right? Because that previous data migration is going to be a problem if you play too much with the with your schema, right? So you need to keep that in mind. So as of today, what we do is essentially is that we have created certain practices that must be followed while making any changes in the schema, because not only it impacts your application code and application behavior, but it also creates a lot of problem, right, for the downstream, right? So people who are using this data to create all these reports, and they have certain understanding of a particular object, right? And all of a sudden you introduced new fields, redundant fields, or nested, objects inside that. They will be thoroughly confused. What does this object actually represent, right? So you have to be very thoughtful in a microservices architecture specifically, that what does this object represent. You have to follow the business language, right? The business understanding very closely with that, right? It cannot be far away from it. So as of today, like I said, most of it is custom code whenever it is required. And we write custom scripts. If we do have to migrate, something that is very, very critical, and it is something that we cannot live with. So yeah, I mean, there is no, at least I don't know, I'm not aware of there is any tool that NoSQL providers have created, right, to manage these things. They have a long way to go before they can catch up with the RDBMS word, right, in this particular direction. So yeah, but hopefully, I don't know, right? Maybe they'll come up. But
one last question: how balance of security and speed could be effectively managed in DevSecOps? Marut, over to you.
Yeah, so I think Chaitanya would be better for this to answer, but let me give it a try. I think in a fast-moving organization like us, right? And when I speak for myself, I talk about, right, a lot of other different startups, right, whose primary job is, right, to capture the customer, right, to reach out to the customer as fast as possible, and right, because speed is your primary mode. If you build product which are not being released fast enough, somebody else will catch up with you, and they will try to beat you in your own game, right? So like I said, right, so it's a question of priority, right? When security becomes high priority for you, at what stage in the organization is a call that you need to take. Now, some technical leaders would like to bake it in right from the beginning, which is also the right thing to do if you talk about pure purists. But you have to realize that what type of team that you have, what is the experience that they have, right? And whether you have enough money to invest into these processes right from the beginning or not, right? But apart from this, as your organization grows, right, these needs become even more important, right? So the moment you are at the risk of losing certain data because people are trying to steal from you because you have become big enough to come into the eyes of your competitors. For example, pricing of the cars, right? People will try to scrape from Cars24 or the leads that we are generating because we are doing this massive marketing campaigns, and all even through organic channels. People know that Cars24 keeps getting these leads, right? Let's go and try to steal them. So security starts playing on your mind more and more, right? And you think about how to address that. So the most important thing is to again take the team on board, make them understand that why this is important in the first place, right? So that is the first layer, right? And then you try to bake it inside your DevSecOps process. But the security team, right, that is actually working, which is defining all these processes, right? They have to interact with all these different teams, right, on a regular basis, make them aware of the best possible practices, why we are doing this. And then security is never static, right? It is always dynamic, right? Because no matter how secure you are, there are companies which are issuing, certificates. Even those companies got hacked, right? Twitter got hacked. There are data leakages from, Facebook, and other companies, right? So the point is, every company, no matter how hard you try, right, leaves, some loopholes here and there. So people have to be aware about this. If they are serious about this, then they will ask you questions, and then you try to bake that in, that, how I'm going to essentially address this. For example, you expose an API to somebody, and it is a business requirement. You need to expose an API. Now, some people will be able to deal with, you generate certificate, you give it to them, and they are able to sort of. But if they don't have a programmer, right, that's another startup which is building a useful software. They don't have enough bandwidth. Then you need to take those risks, right? But how do you protect your environment at the infrastructure level, application layer level, right? User authentication layer level, right? That is something that you need to teach people,
right? So they can take the call that, today I am doing this, but 15 days down the line, this is something that I need to look into and correct this from the security standpoint also. Another aspect, Chaitanya has already mentioned in the very first statement, scanning of static analysis of the code, then a static analysis of the container image itself, right? I mean, which is something that, for example, we push all our artifacts into GCRs. GCR scans all the images and be able to, but you need to see what are the sort of dependencies that you are using inside while building those images. What is the flavor of the operating system? Are you upgrading that on a regular basis whenever the patches are there? Because at the end of the day, Docker image is also containing an operating system layer that needs to be passed into. So right, so at different point in time, you put different focus on depending on the resources, the time that you have, and then you try to basically work upon that. But it is something that is always ongoing. You have to always keep teaching. You have to always keep trying.
Yeah, thank you so much, Marut and Chaitanya. Ladies and gentlemen, we try to take as many questions as we can, but right now we have already crossed our time limit. We try to do justice with your questions, and I'm sure you got answers to all your questions. Once again, thank you so much, Chaitanya and Marut, for this insightful content and your valuable time.
Thank you
Thank
for
you
having us.
to
Thank you.
Thank you to our audience for being interactive and patient and for giving us so many questions to answer. I'm sure a vast audience at the global scale, they got answers to many questions they must be looking at. And finally, thanks to Google Cloud for this collaboration. Ladies and gentlemen, keep following ETCIO for all the latest updates and upcoming events. Take care and stay safe.